Okay, today I am going to explain how to solve partial differential equation with two independent variables. Okay, and this is the last topic of the partial differential equation. See, if it is the PDE with two independent variables, we have to use integral method, direct integration method. Okay, see, we have dou square z by dou x dou y in the left hand side. No need to worry about the right hand side. See here, x and y. This can be done as dou by dou x of dou z by dou y is equal to x by y plus a in the RHS. Now integrate this with respect to what? X. If you integrate dou by dou x of dou z by dou y with respect to x, then it remains only with dou z by dou y. Okay, this is about the left hand side. Now come to the RHS. If you integrate x by y with respect to x, see here we have two terms, x by y constant, 1 by y take outside from the integral, integration of x with respect to x is x square by 2 plus a constant, integration of a with respect to x is a into x plus we have to take integral constant. In the ordinary differential equation, integral constant is c, but in PDE, while integrating with respect to x, take f of y is the integral constant. We have to find f of y by using the given conditions. Okay, this PDE without condition, leave it as it is. If the conditions are given, we have to find f of y. Okay, next, now come to the left hand side. We have dou z by dou y. What is the variable? Y. Now integrate with respect to y. If we integrate dou z by dou y with respect to y, we remains with z only. Okay, now come to the RHS. Here we have x square by y into 2y. Okay, we have to integrate with respect to what? Y. That means x constant, x square by 2 constant. Integration of 1 by y with respect to y is log y plus a constant, x constant. Integration of ax with respect to y is ax into y. Okay, plus integration of f of y with respect to y plus last term is always integral constant. What is the integral constant? G of x. Why it is g of x? Because we integrate with respect to y. While integrating with respect to y, take f of x or function of x is the integral constant. Here we took g of x. Okay, then finally we get z is equal to x square by 2 log y plus axy plus capital F of y is the integration of small f of y. Okay, capital F of y plus g of x. Okay, this is the general form of the solution of partial differential equation. Okay, but in the examination always you will get PDE with some conditions only. If conditions are given, you have to find f of y and g of x. Okay, now come to the next problem. See here. In the second problem, we have dou square z by dou x dou y is equal to sin x sin y, given that dou z by dou y is equal to minus 2 sin y at x is equal to 0. This is your one condition. And second condition is z is equal to 0 at y is equal to 0. Okay, see here, PDE with the conditions are very important. Here, first condition is always partial derivative. This is your second condition. PDE partial derivative with respect to x or y. Okay, here we have with respect to y. If we have condition with dou z by dou y, we have to integrate with respect to x. Very important. Ulta. Dou z by dou y, integrate with respect to x. Suppose if you have dou z by dou x, integrate with respect to y. Okay. Now here given PDE with condition is dou z by dou y. That means first you have to integrate this with respect to x. Okay. Now given PDE is dou square z by dou x dou y is equal to sin x sin y. This can be written as dou by dou x of dou z by dou y is equal to sin x sin y. Okay, now integrate with respect to what? X, because we have dou z by dou y. If we integrate with respect to x, we get dou z by dou y in the left hand side. And sin y constant, because we integrate with respect to x. Okay, function of y constant, sin y into integration of sin x dx. Okay, what is the integration of sin x? Minus cos x. Okay, in the left hand side we get dou z by dou y is equal to sin y minus cos x plus integral constant. What is the integral constant? F of y, because x is the variable here. Integrate with respect to x means take f of y is the integral constant. Next, here left hand side we have dou z by dou y. Now we can apply the first condition to find f of y. Okay, what is first condition? Dou z by dou y is minus 2 sin y at x is equal to 0. Okay, left hand side minus 2 sin y is equal to minus sin y cos 0. Put x is equal to 0 here. Cos 0 plus f of y. Okay, but what is cos 0? 1. Minus 2 sin y is equal to minus sin y plus f of y. Now transfer this into the right hand side. Then you get minus sin y, and it is minus 2 sin y plus sin y if you transfer it. Okay, then f of y is minus sin y. Then substitute f of y is equal to minus sin y in equation number 1. Then equation number 1 becomes dou z by dou y is equal to minus sin y cos x minus sin y. Okay, now what is the variable? Y. Now integrate with respect to y. Now x constant or function of x constant. If you integrate with respect to y, we get a z in the left hand side, cos x and negative sign. Take outside from the integral because cos x is constant. Integration of sin y with respect to y minus second term sin y with respect to y. Okay, what is the integration of sin y? Minus cos y. Then z becomes minus cos x into minus cos y, minus of minus cos y plus what is the integral constant? Function of x is the integral constant because y is the independent variable. Then finally we get z is equal to cos x into cos y plus g of x. Now we have to find g of x using the second condition. Z is equal to 0 at y is equal to 0. Okay, now use second condition. Z is 0 and put y is equal to 0 in all the terms. Then cos 0 is 1, cos 0 1, 0 is equal to cos x into 1 plus g of x. Therefore g of x is minus cos x minus 1. Then substitute g of x in this equation. Okay, in equation number 3. Then finally we get z is equal to cos x cos y plus cos y minus cos x minus 1. Okay, now take cos here, cos x common from these two terms. If you take cos x common, you get cos y minus 1, and we have cos y minus 1. Again cos y minus 1 common, then we get finally z is cos x plus 1 into cos y minus 1 is the solution of the given PDE. Okay, almost all the problems are similar like this only. Okay, now next problem. Dou square z by dou y dou x e power minus y cos x, given that z is equal to 0 at y is equal to 0 and dou z by dou y is equal to 0 at x is equal to 0. This is your first condition. Always condition with PDE is always first condition. Here we have dou z by dou y. That means we have to integrate given PDE with respect to first x. Okay, but here we have y. Interchange these two. Interchange. Then given differential PDE is this one. Dou square z by dou y dou x can be written as dou square z by dou x dou y because these two are always equal. Mixed to second order partial derivatives are always equal. Now integrate with respect to x. Then we get dou z by dou y e power minus y constant integration of cos x with respect to x. Then dou z by dou y is minus e power minus y sin x plus f of y. What is f of y? Integral constant because we integrate with respect to what? X. Now use this condition. Always first condition is condition with ordinary partial derivatives. Okay. Now apply first condition. Dou z by dou y is 0 when x is equal to 0. Substitute sin 0 is 0. Therefore f of x is also here f of y. F of y is 0. Then replace f of I is equal to 0 in equation number 1. Then we get z is equal to dou z by dou y is equal to e power minus y sin x plus 0. Okay, then it remains with e power minus y sin y, x only. What is the variable? Y. Now integrate with respect to y. If you integrate dou z by dou y with respect to y, we get z only. Sin x constant, integration of e power minus y with respect to y. Integration of e power minus y is e power minus y divided by minus 1 plus integral constant is g of x. Now find g of x using the condition, this condition, z is equal to 0 at y is equal to 0. Now put z is equal to 0, y is equal to 0, then g of x is sin x. Now substitute g of x is equal to sin x in equation number 3. Then finally we get z is minus sin x e power minus y plus sin x. Therefore z is equal to sin x into, take sin x common, here sin x into 1 minus e power minus y. Okay. Next problem. Dou square z by dou x dou y is equal to x by y, given that dou z by dou x is equal to log x at y is equal to 1. This is your first condition. In the first condition we have dou z by dou x, means you have to integrate with respect to y. That's it. Okay. Now consider the given PDE. First we have to integrate with respect to y, means first interchange these two. Since we have dou x dou y, let it as dou y dou x. Now integrate with respect to y. Dou z by dou x, left hand side. X constant because we integrating with respect to y. 1 by y dy. Integration of 1 by y is log y plus f of x is the integral constant. Find f of x by using the condition. Now by using this condition, dou z by dou x is log x, x log y, y is 1 plus f of x. Log 1 is 0, f of x is log x only. Then using f of x is equal to log x in equation number 1, we get dou z by dou x is this one. Okay. Now what is the variable? X. Now integrate with respect to x. Now y constant. Then we get z log y constant. Integration of x is x square by 2 plus x log x minus x. Integration of log x is x log x minus x. Very important. Plus g of y. What is g of y? Integral constant. Okay. Now find this g of y using the next condition, that is z is equal to 0 at x is equal to 1. Now left hand side, z is equal to 0, log y, put x is equal to 1, etc. Then finally we get function of y is, g of y is 1 minus 1 by 2 log y. Now substitute here. Then z is x square by 2 log y plus x log x minus x plus 1 minus 1 by 2 log y. Then finally we get this is the solution for the given PDE. Okay. Next one. Dou square z by dou x square is equal to xy. How many independent variables are there? 2 independent variables. But in the left hand side, we have dou square z by dou x square. But in whole PDE contains 2 independent variables. That means it is PDE with 2 independent variables. Given that dou square z by dou x is log of 1 plus y at x is equal to 1 and z is equal to 0 at x is equal to 0. Okay. Now we have to integrate. Here we have dou z by dou x. That means you have to integrate with respect to what? Y. But in the left hand side, we have dou square z by dou x square. That means here we should integrate with respect to x only. Got it? Because given PDE with second order, PDE with x as an independent variable in left hand side. But in the RHS, we have both x and y. Okay, now integrate with respect to x. This comes as like this. If you integrate with respect to x, we get dou z by dou x, xy dx. Y constant. Integration of x is x square by 2 plus f of y is the integral constant. Find f of y using the given condition. Then that is dou z by dou x is log of 1 plus y at x is equal to 1. Now substitute here. Then f of y is log of 1 plus y minus y by 2. Now substitute f of y in 1. Then again we have to integrate with respect to what? X only, because we have x in the left hand side. Okay, now integrate it. Okay, if you integrate, we get y by 2 constant, x square, integration of x square is x cube by 3, log of 1 plus y constant, integration of 1 is x, y by 2 constant, integration of 1 is x, plus Again, function of y is the integral constant. Here we took f of y, here g of y. Okay, now find g of y using the second condition, z is equal to 0 at x is equal to 1. Now using this condition, z is equal to 0 at x is equal to 0, finally g of y is 0. Now substitute here. Then z is y x cube by 6 plus x log 1 plus y minus xy by 2. Okay, this is about your partial differential equation model 4. Okay.